All right, so the final lesson that we're going to take a look at in measurement is volume of composite shapes. Okay, we can also name it as composite objects. I often use that term as well. But when we talk about, again, composite shapes, we're talking about when we have two or more shapes put together. Okay, we've gone through that with surface area, so we understand at least the concept of composite shapes. Now we're going to take a look at finding volume instead of finding surface area. When finding the volume of an object, there is no need to be aware of covered sides as there is in surface area or missing pieces. Okay, so in surface area, we had to worry about, are there sides that are covered up? Do we have to subtract certain pieces or anything like that? In volume, we don't need to really worry about that to that extent. It's a little bit different. It's a little bit more straightforward with how we find the volume of a composite object. Now, all we need to do is just find the volumes of each shape. And then once we've done that, we add or subtract, add or subtract them to solve. So I don't want to go through and just say it's easy. It's not necessarily easy, but it is a little bit more straightforward than finding the surface area of a composite shape. Volume tends to be a little bit more straightforward. So let's take a look at example number 1 here. We have two shapes put together. We want to find the volume of this composite shape. Well, the shapes that we have is we have a cone, and I'm just going to quickly write that in here. We've got a cone on top, and we have a hemisphere on the bottom. Okay, we've got a cone and a hemisphere. So these two shapes, let's see if we can maybe change. Try this again. There we go. We have a cone and we have a hemisphere. These two shapes have been put together. Okay? Now we can think of it as being two shapes combined. Now take a look here in this small video. I have two little pieces here. We have a cone and we have a hemisphere. We're putting them together into one. Think of it as being like a little top, so to speak, or we can think of it as upside down ice cream cone. Okay, we have the two shapes being put together into one, and so we need to find the volume of the entire thing. To do that, we find the volume of each one individually. So I'm going to start with the volume of a cone, and I'm going to label it volume. Let's do a little differently. We're going to just put, we're just going to label it nicely here. See if this is going to work. We have our cone, and to find the volume of a cone, volume is equal to pi r squared times h divided by 3. That's going to be the volume of our cone. Now we are given the radius, we're given the height, so that part is already taken care of. So volume is equal to pi, and then we have our radius, which is 4 centimeters squared, and then we're going to multiply by our height, which is 10 centimeters, divide this all by 3. Get the V in there. So when we solve this, we're going to put it into our calculator here. Let it load up. So we have pi times 4 squared, not times our height, which is 10, and then we're going to divide this all by 3. Okay, so remember, it's just the radius that is squared, not the rest of it, just the radius. So it's pi times radius squared times our height, and we divide that all by 3, and we get an answer of 167.55 centimeters cubed. So we put in our volume there, 160, I'll double check again, 67.55 centimeters. There we go, cubed. All right, there's our cone. So our cone is found that way. We again just use our regular formula to find a cone. Now the hemisphere, Same thing. We use our hemisphere formula. It seems to be going nice and slow here today for whatever reason. And so the volume of our hemisphere, now you'll notice I'm labeling it. This is cone, this is hemisphere. It's going to be 2 pi r cubed divided by 3. Now you have your formula page, you can put that on there. Hemisphere is not on there, but you can definitely put that one on there. Volume is equal to 2 pi, and then we have our radius of 4 centimeters cubed divided by 3. Okay, plug that into the calculator. I'll do that in 1 second here. Volume equals, so it's going to be 2 times pi times 4 cubed, space, divided by 3. And we get 134.04 centimeters cubed. All right, so we have our hemisphere and we have our cone. Now, the fact of the matter is that they're being put together, so all we're going to do is add them. And so to find our total, we add the two totals together. So when we do, so this is our total volume. And so I'm going to use volume is equal to 167.55 centimeters cubed, plus we just add them, centimeters cubed. And when we do that, we get a total of, let me use my calculator here instead of that one, I find it a little bit quicker, 134.04, 301.59 centimeters cubed. And that's our total volume. So what we've done now is we found the volume of the cone, we found the volume of the hemisphere, we add them together because it is combined, okay? We are combining them. The other case that we could have is something that looks like this. So in this case here, we're told that we have a steel ornament that is made in the shape of a box. You'll notice it's a cube with a cone cut out of it. Okay, here's our cone that's cut out. Determine the amount of steel that's needed to make each ornament. Now, unlike the first one where we add the two pieces together, here we're cutting something out. So we need to now subtract them. Okay, the cone is going to be subtracted from the cube. So we have a cube. And there's our first one, and I'm going to find the volume of that cube. So we have volume of a rectangular prism or a cube. In this case here is just going to be the base length cubed. That's it. Length times width times height. They're all exactly the same. So I'm just going to do 6 cubed. So volume is equal to 6 centimeters cubed. And our total volume we have 6 to the power of 3, 216. So we have a volume of 216 centimeters cubed. That's for our cube. Yes, and it is cubed. The other thing that we have in here that you'll also notice is we also have a cone. Okay, and the cone is being cut out of it. But we still need to find the total volume of the cone. So unlike surface area where we had to, we actually added in some of that cone, we're actually going to subtract the whole thing because the volume of the cone is being taken out. The volume of a cone is pi r squared h divided by 3. Now something about this cone that you might notice is I haven't actually given a height for this cone. Okay. Our radius is 2 centimeters. Due to the diameter being 4. The height, it looks, if we're not given a height, we're going to assume that it goes all the way through, so it's going to be the full 6 centimeters. Divide that by 3. And we get a volume of, so pi times 2 squared, so where the sign came in here, 2 squared times 6 divided by 3, and we get 25.13. So our volume is 25.13 centimeters cubed. Now, the cone is being cut out of the cube. That means the cone needs to be smaller, and it is. Okay, and that is very important. If it is in fact also bigger, then we may have made a mistake in the way that we did our calculations. Okay, so double check that. If all of a sudden the piece that's been cut out is bigger, we may have made a mistake. Total volume. Okay, so now we got our volume is equal to our big shape, centimeters cubed, minus our small one, 25.13 centimeters cubed. And that is happen again. Volume is equal to 216 minus 25.13, and this is 190.87 centimeters cubed. At 190.87 centimeters cubed. Move that over there. There we go. We got it nicely lined up there. So that's then our total volume. In this case here, we needed to subtract. In the previous one, we needed to add due to the fact that they are combined or taken out. All right, then final thing is here, we need to have our assignment. The assignment is going to be the entire ME.01, or sorry, 09, numbers 1 to 8. So that is the entire assignment. Please work on that. Make sure you're showing your work. Make sure you're showing each piece, especially when it comes to the weekly progress check. You're showing each piece and how you solve for it.